Hey, welcome back. We are here talking a little bit more about within subjects designs and what's good about them and what's not so good about them. So let's talk about some of those advantages. So one of the things that's really kind of cool, again, I'm kind of making myself float around here. It's kind of fun. Generally, one of the things that's kind of nice about within subjects designs, first of all, so compare this to an independent groups design, for example. You don't have to worry about balancing groups because everybody is basically functioning as their own control. So you're not necessarily looking at the difference between different people. You're looking at the performance of each person in these different experimental conditions because they're getting exposed to all of them. And then you aggregate that to see those differences across people. So you're less interested in groups of people and you're more interested in how each individual person is doing on these conditions, and then you basically take that in aggregate. So you don't have to worry about things like random assignment. You should still probably do it if you're doing between subjects designs, though. But participants in a within groups design or a within subjects design are equivalent because they're always going to be the same participant and they serve as their own controls. And because everybody is functioning as their own control, it actually can lead to bigger statistical effects, and it also makes the design more sensitive to statistical effects. So we often tend to say that compared to between groups designs, within subjects designs tend to be incredibly powerful. It's a lot easier to notice differences between conditions when everybody's functioning as their own control and they're exposed to all conditions. And additionally, one of the things that's especially nice is that within groups designs typically will require fewer participants. So whereas you might need two groups of 20 people each for an independent groups design or a between subjects design, so we have these two different conditions, you just need half that, because they're getting exposed to both conditions. So you can get away with having fewer participants with a within subjects design. And this is often what I do in my experiments. I expose participants to all possible experimental conditions. Usually there are at least 6. They get multiple trials per condition. Those are completely randomized, and they usually get about 300 to 400 trials per person. Now, when you factor in that I've maybe got 25 to 30 people, that is a lot of data to work with. And generally, larger sample size is always better, but you can get away with having a smaller sample size if you're doing a within subjects design. Now, having said that, there are a couple of things you have to watch out for when you are doing a within subjects design. So you can, basically one of the things you have to watch out for is what is called an order effect. So generally, when you are exposed to one experimental condition, it will affect how you perform on other conditions as well. And that is something that if you are exposing people to all possible conditions, you're going to have to watch out for. So what are some different examples of order effects? Well, probably the best known is what is known as a practice effect. So usually when you first are taking part in an experiment, you're learning how to do the task or follow the instructions. And because you're new to it, you're probably going to do worse on those first few trials than you would later on. Or you're going to do worse on that first condition than you would in a later condition. And so that's what's called a practice effect. Additionally, a different type of order effect is what is known as a fatigue effect. The longer that you go on doing an experiment, the more tired, the more bored you get, and the worse you will tend to perform on later conditions or later trials. A couple of different simple things that you can do to try to get rid of those practice effects is, first of all, give people practice trials. Give them a series of practice trials so that by the time you start the actual experiment, they know what they're doing. For fatigue effects, you can encourage people to take breaks. Most of my experiments are self-paced, so to start another trial, they have to hit a button. So if they need to take a break, stretch, look at something that's not a computer screen, they can do that. Now, having said that, we still are going to potentially have practice effects and fatigue effects. And having practice trials or allowing people to take breaks may not be enough. So what you should also do, and we'll talk about this a little bit more soon, is a process called counterbalancing. You want to make sure as often as possible that no one experimental condition within subject's design is getting an advantage over another. You don't want the exact same condition across participants to always be last, because they'll probably tank that because of a fatigue effect, and that creates a confound. Did they do badly because it's hard, or did they do bad because they're tired? So you want to try to, as often as possible, counterbalance. Something else that you have to watch out for is a carryover effect. So this is a case where maybe I teach you a strategy. So, for example, I give you a list of words in one condition and I say, okay, make a sentence with these words, out of these words. Try to see if you can make a sentence and help you remember them. In the next condition, I go, okay, now this time I don't want you to do what I just taught you. Now, odds are pretty good now that I've taught you to do that strategy. Odds are pretty good you can't unlearn that. And you might, even though I told you not to, you might still engage in that strategy. It's part of the reason why within subjects designs don't always work well when you're trying to teach people new strategies, because once they learn it, they can't unlearn it. But this is another case where carryover effects can be helped by counterbalancing. So here are a couple of different examples. Your book goes into more detail. You can do full counterbalancing. So what you can do is you can keep track of how many different conditions you have and scramble them in all possible orders and assign each participant to one of those specified orders. Now, the problem with this is you can't have too many conditions for this. And this is because for every condition that you have, the number of counterbalanced orders that you would need is based on a factorial. So if I have two conditions, I only have two different orders. That's pretty easy. If I have three, I now have 6 separate orders that I can do things. So 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So already there, it's getting more complicated. By the time that you get to 4 different experimental conditions, you have to have 24 separate conditions. So I hope you have at least 24 people. And if you have 5, well, heaven help you. At this point, you have to have 120 separate orders. So full counterbalancing tends to work best if you have 4 different conditions. And honestly, I would even say 3 or fewer. Do full counterbalancing. If you can't, you can do what is called partial counterbalancing. So for example, I do partial counterbalancing in all of my experiments. So what I do, I usually program my experiments to basically randomize all possible conditions across participants. Is it a full counterbalancing? Probably not, but it gets the job done. And as long as I've got enough people, no one condition is always going to be first. No one condition is always going to be last. So I'm not giving preferential treatment to any one condition. Another thing that you can do is what I'm showing you down here. This is what is called a Latin square. So I have 4 different participants. I have 4 different conditions. So what I do is for each participant, I write down the 4 different conditions, A, B, C, D for the first order. Then I basically move B up. A goes all the way down to the bottom. So now I have B, C, D, A. Then I have D, A, B, C, C, D, A, B. So in this case, what I have basically done is rotated these in a Latin square. So obviously, it's not full counterbalancing. We don't have 24 different orders here, but it's good enough that no one condition is advantaged. A is only presented first once. It's only presented second once. It's only presented third once. It's only presented fourth once. The same is true with B. The same is true with C, and the same is true with D. So no one condition gets, every condition appears in each possible position just once. So there's no advantage here. So be prepared to use tricks like these if you're planning on doing a within subjects design so that you're not creating order effects. Now, what are some other disadvantages? So there is that potential for order effects. If you counterbalance, that's not an issue. If you're teaching a strategy, or if there's a special twist in your experiment, it may not be practical or possible. If you teach somebody a strategy and then you say in the next condition, hey, you know that strategy I taught you? Don't do that anymore. You can't unlearn that. So don't really do that for strategies. Additionally, it's entirely possible that being exposed to all possible conditions may change the way that participants act and create a demand characteristic. They behave the way we expect them to behave because they figured out the true purpose of the experiment. I've thankfully not had that happen to me very much, and I think that's largely because my experiments are kind of boring. But if yours are far more engaging, this is something you might want to watch out for. And there are some ways that you can deal with that. So a quick question becomes, is the pretest post-test design a repeated measures design? And it absolutely can be in a manner of speaking. So here is our pretest post-test design. So we have our pretest, we have our exposure, we have our post-test. Everybody gets exposed to everything. You can have a very similar sort of setup with a repeated measures design. So we randomly expose people to level A and we measure it, expose to level B and measure it, and the same sort of thing. So you could think of pretest post-test as being somewhat of a simpler version of a repeated measures design. Now let's talk about the 4 different validities and experiments. So again, let's talk about those 4 different validities and how we can use them to think about experiments more deeply. So we're going to talk about construct validity. How well were our variables measured? How well were they manipulated? External validity. To whom or to what can our causal claim generalize? Statistical validity, how well do our data support the claim? And internal validity, which is probably the most important for experiments, are there alternative explanations for our outcome? So let's start by talking about construct validity. So first of all, we need to keep in mind that we are looking at 2 different variables. So for our dependent variables, we want to make sure that we've measured them well, that they're reliable, that we're recording them consistently, and so on. With independent variables, we want to see how well they're manipulated. And there are 2 different ways that we can do this. We can do this with something called a manipulation check, and we can do this with something called a pilot study. So for a manipulation check, a very common way of looking at the effect of emotion on different types of psychological processes that researchers like to do is something called a mood induction. So they like to temporarily create an emotion in somebody that will influence future behavior. So you want to make sure that that works. You want to make sure that your mood induction worked. And so what you can do is you can do a manipulation check. You can do a quick survey or a quick measure to see if I induce these people to feel sad, do they actually feel sad? If I've induced people to feel happy, do they actually feel happy? So that's one thing that we can do to make sure that our manipulation is working as it should. Another thing that we can do is what is called a pilot study. So I often will pilot before I ever actually do an experiment, a full experiment, because I want to make sure that I'm actually looking at something real. There have been instances where I've created research ideas, and from piloting, I discovered that this was an effect I was not going to be able to find, and my time would be better spent elsewhere. So what we typically do with a pilot study, it's kind of a preliminary version of our experiment. We test it out on a small group of people that we don't call back for the actual experiment, just to make sure that things are working as they should and to help work out any of the kinks. Now, with external validity, generally, this is something that is a little less important for experimental research. That cause-effect relationship is far more important. Now, having said that, especially for a lot of the work that I do, I'm very, very interested in making sure that my findings do generalize to other people. Everybody has working memory abilities. Everybody has attentional abilities. And one of the things that I think that the correlation studies, what I talked about last time, I think is pretty important here too. So oftentimes with my data, it's all about really what you prioritize. And for me, I'm typically prioritizing basic low-level processes at people when they're at their best, which is usually around college age. So I will be the first to say that, obviously, as this changes with age, we do see differences. So the findings we get from young adults may not necessarily generalize to older adults. And that's why it's important to do research on other groups of people before you make bold claims. So you may want to generalize to other people. You may want to generalize to other cultures or situations. So for example, in sensation and perception, I've been talking about music perception. And it turns out, depending on where you are from in the world, music tends to fall on a different type of scale. So for example, here in the West, we tend to follow a 7-note scale, I think a heptatonic scale. Other cultures tend to follow a pentatonic scale based on 5 notes. And that's going to potentially affect how they perceive aspects of music. So if we want to look at those differences, we need to try to incorporate those differences. Now, here's the thing. If external validity is poor, that doesn't necessarily mean that the research doesn't have its place. It just means that it might be a little bit more restrictive in scope. Everybody has a working memory capacity. I can make some pretty good claims about young adults, and I can generally say, based on what I know with the research done on older adults, that their abilities are going to be a little bit less. But if I want to find that out for myself, I want to make sure I have a pretty representative sample in my experiment. And in that case, what I would personally do is introduce a factorial design and look at this task with a group of young adults and older adults and make comparisons. And we'll talk more about factorial designs too soon. They tend to have a little bit more external validity than a single factor design will. And we'll get there in about 2 weeks. Statistical validity is probably going to be far more important for experiments. And that's because we want to make sure that our results actually have an effect. So the big questions that you need to be asking yourself when you are looking at data is this difference statistically significant? So here you can kind of see that we typically, when we're looking at research, we tend to either look at a t-test, which is based on condition means or group means, or we tend to look at an f-test, which is based on overall patterns of variance and variability between groups. So you can kind of see that we definitely have some variability across these different conditions. Now, what's especially important here is that comparing group 1 to group 2, here are instances where we have the same means across each group, but they've got different amounts of spread. So in this case, the group means are the same, but we can do a measure of effect size known as Cohen's d. And you can see that the effect for this first instance is much, much larger than this other instance. And we'll talk some more about these types of statistics next semester. Please don't be scared. It'll be okay. But these are the guidelines for Cohen's d's effect size strength. So this is pretty similar to the guidelines for correlation coefficients. So a Cohen's d of 0.2 is a pretty weak effect. So basically this. A Cohen's d of 0.5 is a moderate effect, such as you see here. And a Cohen's d of 0.8 is a very large effect.